Hi guys, my name is Dmitry and I welcome you on my technical channel. Today we are going to continue our experiments with FPGA using RTZ7 board. In our previous workshop we began designing a ZX Spectrum video controller capable of displaying pixel data. In the end we managed to display a black and white screenshot. Today we will add support of color attributes and make some additional improvements to the controller. So let's start. My hardware connection is still the same. I'm using RTZ7 board. The power supply is provided by the micro USB cable, which is also used for serial output and JTAG interface. HDMI cable is connected to HDMI out, which is a sourcing connector. Let's quickly go back to the results that we previously achieved. We managed to display black and white pixel data. The aspect ratio wasn't correct, but this is because we didn't use proper widescreen resolution, which we're going to fix today. The color attributes were not supported at the time. This is what we are going to change today. This is how the picture in colors should look like, and the proper aspect ratio as well. Going back to the architecture, we had only one FIFO capable of fetching black and white pixel data from video RAM, and this is why it wasn't, and it is still not capable of displaying color attributes. Color attributes are kept in a separate area. This is the specifics of ZX Spectrum video memory layout. When one color attribute defines colors for a block of pixels 8 by 8, which obviously has its own limitations, but that's a well-known fact. We are going to extend our architecture. So instead of one FIFO, we will have two. The second one will be responsible for the keeping data reflecting color attributes. The number of processes is still the same, but we will extend logic inside AMBA FSM process and inside color generator. So the AXI transactions will be interleaved between the two FIFOs. The amount of data pushed into pixel FIFO and color FIFO will be the same. Maybe it's not very optimal solution, but at least it is the easiest one to implement. And then we're definitely not suffering from lack of performance yet. So let's leave it this way. You can see that there is a demultiplexer, so each FIFO gets connected in its own turn to the output of the AMBA FSM process. Now let's have a look at the scope of changes in the HDL code. So we switched to widescreen. We switched to 1280 pixels per 720. We introduced ranges for those constants, which is a good practice. We initialized scaling factor and set it to 3, which means that we will need to upscale the ZX Spectrum frame 3 times. Maximum brightness, we just renamed those constants. Additional address that represents the beginning of color attributes, which is shifted by 1800 in hex. (1800) in hex, as you can see, relative to the beginning of pixel data. Now we added a few counters. This one is to support upscaling. This one is to support so-called flash attributes. So we count frames and then we make a decision on whether to flip the state of the color attribute. Those are a bunch of signals to support the second FIFO, and those are additional signals, counters, to support color attributes as well. So as you can see, we instantiate the same FIFO, 64 by 512. This is going to keep our color attributes, mapped its inputs and outputs to our signals. This logic allows us to interleave between pixel data FIFO and color attribute FIFO. Depending on pixel attribute selector, we either enable writing into pixel data FIFO or color attribute FIFO. Now, let's have a look at the changes inside Amber FSM process. So we added a few signals, so we simply initialize them to their initial state. Upon reset, there is a little bit more sophisticated logic while we are in idle state. We don't start unless both FIFOs contain some information which is enough for one scan line. And again, we interleave between two addresses, either pixel data address or color attribute address, depending on the state of attribute selector. Now you can see that there is a lot of changes in done state, but in essence it is very simple. When we are in pixel data mode, we keep the same pixel address to retrieve multiple scan lines to achieve scaling effect. And then we flip the pixel attribute selector, so we switch into attribute mode. In attribute mode, we work out the next address for the color attributes, and again same logic applies. We keep the same address for several scan lines to achieve scaling effect, and then at the end again we flip back to the pixel mode. So this is how we interleave between two FIFOs. This allows us to work out color attribute offset based on the vertical count. So it's like an auxiliary function. Now there is a color generator process which has undergone significant changes as well. Again, in terms of logic, it has been changed due to support of a scaling factor. In order for us to work out intensity for each of the three color components, we need to take into account much more parameters. This is why it becomes a little bit more sophisticated comparing to the previous logic. Yeah, and we have a frame counter, which is used for supporting flashing attributes. That's about it. That is pretty much all the changes, as you can see. Let's synthesize, build Vivado project and see what happens. We are back to Vivado, but before synthesizing it, let's open block design. And let's get rid of axis stream subset converter. Video in. Let's have a look what it does. As you can see, it swaps the 8-bit from the middle with the least significant bits. And we can do it in our design. Let's go to the source code. Simply speaking, we need to swap blue component with green. Blue, green. Red is still the same. Save. Open block design. Delete this one. Delete this one. So let's delete this one as well. And simply make external. Make external. This should be enough. Save it. Run synthesis. Before I could get a successful synthesis, I had to remove T-keep signal from my design because it doesn't have it anymore. As you can see, T-data, T-last, T-ready, T-user, T-valid. There is no T-keep. So this is what I did. We didn't use it anyway. T-keep is disabled at the moment, and then on the top level design, T-keep is also removed from everywhere. So let's get back to our design and check that we don't have any debug. Nothing. All good. Now run implementation. And and I'm going to switch my camera off. Implementation complete. Let's generate bitstream. I'm going to switch my camera off again. Bitstream is ready. Let's export it. Now let's try to run it without uploading any image into the video memory. And as you can see, we have colors. Slash and attributes seems to be working as well. Brightness, high brightness attributes seems to be working also. Let's try to load the picture. Right at the beginning of the video memory. And we have a proper picture by the look of things. The aspect ratio is correct now. The colors seem to be okay, even though there is a problem between the bright and not very bright attributes. Looks like that we need to adjust the intensity of the colors which are not bright, without bright attribute. There is also a little bit of noise at the right edge of the frame, so it looks like we have a problem. But nevertheless, we achieved our goal for today, and next time we will fix those outstanding issues and we will add additional functionality on top of the existing one. Please like the video if you like it. Please hit the subscribe button so you won't miss the new videos released in the future. And until then, see you later. Bye.